Assalamualaikum warahmatullahi wabarakatuh. My name is Niken Kusuma Ayu Fadhila. I'm from Mathematics Education University of Movavi, Professor Dr. UHAMKA. In this video, I will explain about quadratic equation. I hope this video will be useful for all of us. Keep watching my video and enjoy!
Quadratic equation. In this video, I would like to explain about definition of quadratic equation, graphical form of quadratic equation, how to solve the quadratic equation problem, and discriminant of quadratic equation. Let's start by definition of quadratic equation. The name quadratics come from quad, meaning square, because the variable gets squared like x squared. The general form of a quadratic equation look like this. ax squared plus bx plus c equals 0, where a, b, and c is element of real number, and a is not equal 0. X is the variable. Now move on to graphical form of quadratic equation. Quadratic equation, if drawn in the form of Cartesian coordinates x and y, it will form a parabolic graph. Therefore, quadratic equations are also often called as parabolic equation. The value of a determines the concave or convex parabolic curve. If the value of a greater than 0, then the parabolic curve will open up or concave. Conversely, if a is less than 0, then the parabolic curve will open down or convex. The value of b in the equation determines the peak position of the curve. In other words, determine the value of the curve symmetry axis, which is equal to x equals minus b over 2a. The peak is in the left of the y-axis if a times b less than 0. The peak is in the y-axis if the b is equal 0. And the peak is in the right of the y-axis if ab greater than 0. The constant value c on the equation graph determines the intersection of the parabolic function with the y-axis. Intersects in the positive y-axis when c is greater than 0. The graph intersects the y-axis at the center when c is equal 0. Intersect in the negative y-axis when c is less than 0. Let's look at how to solve quadratic equation. The solution of the quadratic equation are called roots or sometimes zeros. There are three ways to solve the quadratic equation. First, factoring. Second is completing a perfect square. And the last is ABC formula. The first is factoring. It is called factoring because we find the factor. This method is easy to use if the roots are rational number. The following table models quadratic equation and various ways of factoring. When using this method, we must know the quadratic equation model to be solved. If the quadratic equation model is known, factoring can be done in the form that is in the table column up like this. Second is completing a perfect square. The method of completing a perfect square will be easy to use if the coefficient a is made up to be 1. The quadratic equation in the form ax squared plus bx plus c equals 0 is transformed into an equation in bracket x plus p squared plus q, where p and q are constants and x is variable. The values of the constant p and q are the equation x squared plus bx plus c equals 0 are obtained by p equals half b and q are equals in bracket half b squared minus c. The last is ABC formula. The ABC formula method can be used if factoring and completing a perfect square cannot be done. The value of the roots of the quadratic equation ax squared plus bx plus c equals 0 are obtained from the following ABC formula. x1.2 equals minus b plus minus in root b squared minus 4ac over 2a. So, the root are x1 equals minus b plus in root b squared minus 4ac over 2a, and x2 equals minus b minus in root b squared minus 4ac over 2a. Now, move on to discriminant of quadratic equation. The types of root of the quadratic equation ax squared plus bx plus c equals 0 can be determined by knowing the value of discriminant d. The discriminant value is contained in the ABC formula as b equals b squared minus 4ac. So the ABC formula becomes x1.2 equals negative b plus minus in root d over 2a. The discriminant root signs like this. In the ABC formula determines the type of square root equation, whether a real number or not is real. So the quadratic equation root types of ax squared plus bx plus c equals 0 are if d less than 0, then the roots are not real. If d greater than 0, then the roots are real, where x1 and x2 is the element of real number and difference. x1 is not equal x2. If d equals 0, then the roots are real, where x1 and x2 is the element of real number and equal or x1 is equal x2. This is the reference that I use in this slide.